Okay, when solving a story problem by substitution, you have to isolate one of the letters, either T sub 1 or T sub 2. I'm going to choose to work with this second equation. And the reason I'm going to do that is when I get this term over to this side of the equal sign, it will become positive, and then I don't have any negative signs to deal with. So I'm going to add 0.82 T sub 2 to both sides of this equation. So again, I'm working with the second equation. So on the left side, I'll have 0.73 T sub 1 equals 0.82 T sub 2. Now, I want to solve for one of these letters. I'm just going to solve for T sub 1 because it's on the left, and I just like to see my letter that's all alone on the left. So I'm going to divide both sides by 0.73. And when I take my calculator and I take 0.82 and divide it by 0.73, I get 1.123. So check that out. Make sure you get that. But it's just the division process. Put this in first, divided by that number. Now, I'm going to substitute this right here in for T sub 1 in the other equation, the one I didn't work with. So that's going to be 0.68 because that's what's in front of the letter T sub 1. But now I'm going to put in 1.123 T sub 2 in there. There is a 0.57 T sub 2 as the second term right here equals the 750. So now I'm going to get my calculator out and I'm going to multiply those two numbers together. I'm just going to tell you what they are. So 1.123 times 0.68. Actually, I'll go ahead and write it down. So that's 0.76. I'm going to round that to 4 T sub 2. And I got to add 0.57 T sub 2 to that because those are like terms. So this decimal number and this decimal number add up to be about 1.33. And I don't know why I have an 8 in my notes, but I just do. It probably should be a 4 based on how I rounded this off right here. So plus 0.57, I'm just going to check. Yeah, 1.334 T sub 2, and then that equals the 750. So now I divide both sides by 1.334 and 750, and I'm dividing by the full value, the 1.3364. And so I get T sub 2 equals 562.4. Now this is tension in newtons. And if you were in my statics class, you'd learn how to set up this equation. It's a civil engineering course. So, you know, that is a physics course. Now, once I know T sub 2, I go ahead and go into this rearranged equation over here, and I just take this 1.123 and I multiply it by the 562.4 newtons, and I get 631.4 newtons. Now, don't forget, I have my two solutions now. I have T sub 1 equals 631 and T sub 2 equals 562. I would check this now on my calculator. So I'm going to pull up my calculator and I'm going to take my two solutions. Let's see if I can see them both. I have them on my notes. Let's see if I can get this. So the first statement says take 0.68 times T sub 1. So I'm going to take 0.68 times the 631.4. And then it says add 0.57 times T sub 2, which is 562.4. And you have your paper there. It's supposed to equal 750. That's close enough. Now do the next one. So 0.73 times T sub 1, which is 631.4. And then subtract 0.82 times the 562.4, and I believe that one's supposed to equal 0, and that's close enough. So I know that I've gotten these correct. Let's do another story. This one we'll have to write our own formula for. So pause the video and read this problem so that you can get ready to set it up with me. Okay, so x is going to be, it does say here at the very end, how many of each type were sold. We're talking about wire-bound graph paper notebooks and college rule notebooks, and I want to know how many. So I'm just going to say here that X is going to represent the number of wire-bound notebooks, and Y is going to represent the number of college rule. So you really need to come out and say what X and Y represent. Very, very important. It tells us the cost for each. And it tells us at the start of a recent semester, 50 of these notebooks were sold. Here, the question is, how many of these notebooks were sold? And 50 of them were sold. So maybe 10 of this one and 40 of this one. Maybe 20 of this one and 30 of this one. But the bottom line is these two letters have to add up to be 50 notebooks because they represent the number of notebooks, and they told us that 50 were sold. I call this my total equation. In many of these physics and chemistry problems that you're going to see with me, we have this total statement about how many notebooks, how many ounces, how many pounds, how many newtons of force. So there's my total statement. My next statement is going to be about the value of what got sold, and the total sales was $118.60. So if you sold 10 of the wire-bound notebooks at $2.50 a piece, you take $2.50 times 10 would be $25. So why don't we take $2.50 times X, the number of notebooks, and $2.30 times Y, the number of notebooks, and that should equal the total value of notebooks that have been sold. Then I've got my two equations in two variables. I'm going to take this equation and I'm going to subtract X from both sides. So I'll have Y equals 50 minus X. From now I'm just going to throw that X over to the right side. It's called transposing. So instead of writing this statement right there, I'm just going to say if X is positive on the left, over on the right, it's going to become minus. And now I'm going to substitute in 50 minus X in for Y right here in the second equation. Substitution is a wonderful method of solving a system of equations. So I'm going to substitute in for Y of 50 minus X. And now I've got to do the algebra that results from this. So I'm going to take $2.30 times 50, and that's going to give me 115. And 230 times this minus X is a minus 230X. Over here, 250X, don't forget to bring that down, equals 118.60. The 2.50 minus the 2.30 is 0.20x. If you don't mind, I'm going to subtract 115 at the same time as I combined those like terms. So I'm actually going to move this 0.20 over here. And this subtraction is going to result in $3.60. And when you divide both sides by 20 cents, 0.20, you're going to get that X is equal to 18 wire-bound notebooks. So X is equal to 18. I'm going to come over here and say X is equal to 18. From there, I'm just going to take 50 minus 18 and find out that Y is equal to 32, because I need these two to add up to 50. And so I don't even have to check that statement, but what I am going to do is I am going to take the $2.50 per wire bound times 18 of them, plus the $2.30 times 32 of those, and see if that dollar amount is the $118.60 that the value of those should be. And I know I got this question correct. Let's go ahead and set up the next problem. So the sum of two numbers is 50. Well, that's pretty simple. X plus Y is 50. I hope I said 50 just now. The first number, that's X, is the first number, X, equals 25% of the second number. The second number is the letter Y. the first number is 25% of the second. This is nice because x is already solved for. So for x in the first equation, I'm going to put in a 0.25. And so I'll have 0.25y plus, don't forget that's a 1y equals 50. And 1 plus 0.25 is 1.25y. And then when I divide both sides by 1.25, I get y is equal to 40. Remember, the sum of the two numbers is 50, so I can say x is equal to 10 because that's got to add up to be 50. And then I'm going to say, does x, which is 10, turn out to be 25% of y, which is 40? It sure does. And so that checks as well. I'm going to stop right here. I'm not sure I'm going to do the next two problems. I'm going to let you think about those on your own. I'm going to, in my next segment, move on to solving systems of equations algebraically by elimination.